So we're now going to be starting topic 2. Remember, a topic just means chapter usually, but this book calls it a topic. It's one of my favorite topics. We get to talk about graphing and different types of equations, slope-intercept, point slope, and standard form. And so I really like this unit a lot. I hope you enjoy it too. So the first thing we're going to do, we're going to just make sure that we review some information and then go over some stuff that you might not have gotten previously. So we just want to make sure you're aware of it. Nothing difficult, just something maybe you haven't learned. So this part shouldn't be too difficult for you. Tell whether the ordered pair is a solution of the equation. Just substitute x and y to see if the equation works. Now when we say that it works, then it has to be the same thing on both sides of the equal sign. Write solution if it works, not solution if it doesn't. So take this first one. Remember, this is my x value, this is my y value. And we're just going to plug it into the equation. So in place of y, I put a 10. In place of x, I put a 2. And then I see if we come up with the same thing. So this is 10. This gives me 4 times 2, which is 8. So 8 plus 2 does give me 10. So it gives me, it works, as they say it, but it's the same thing on both sides. So therefore, yes, this is a solution. Okay, let's look at number 2. With number 2, we do the same thing. Again, this is x, this is y. So in place of x, I'm going to put 7. And in place of y, I'm going to put 5. So this side is totally simplified. I'm just going to leave it alone. I'm going to do this side. 2 times 7 is 14, plus 5 gives me 19. Is that equal to 5? No. So this is not a solution. Not a solution. So we don't say no solution here. We actually have to say not a solution. And this is helpful because we're going to try lots of different points, okay? So I think you get the idea. I'd like you to try number 3 on your own. So pause yours. Try it, and then we're going to come back and talk. Go. So you plugged in 3 for y, negative 3 for x. This is 6 minus a negative 3, so that'd be 6 plus 3, it's a 9. So does 9 equal 3? No, it does not, so this is not a solution. Okay, you'll come back and do 4, 5, and 6 later on. Let's move on. Okay, now this is where we have an equation. We're going to pick some numbers and put it in. They actually pick the numbers for us on some of these. Sometimes we'll pick our own. And all we're going to do is we're going to plug in these values to find the y value. Then we're going to write an ordered pair. So I plug in 7 for x. So I have 7 plus 2, which is 9. So my ordered pair is 7, 9. Then I plug in 4. And I get the point 4, 6. Because remember, this is your x. This is my y. And we always pick the x values. Well, not always, but 99.9% of the time we're going to pick it. Now I plug 0 in, and I get 2, so my point is 0, 2. Okay, so let's plot those points now. We have 7, 9. So I go 7 on the x-axis, 9 on the y-axis, so there's my first point. Can you see that? Yeah, you can see that fine. I'll switch to red just in case. And then we go 4 and 6. And then we go 0 and 2. Now, notice they don't all have to be consecutive right after each other because they weren't up here either. Then we draw a line. If you have a straight edge, yeah, that's awesome. Now, when we draw a line, our line should go to the edges of the grid, and we always put an arrowhead on because these lines continue forever and ever. These are all points. These are all solutions to this equation. These were just what we call our whole number points. So they hit at a cross. So what I mean by a cross, here's a crossbar. Now I want to look at this number in particular, this one right here. Okay, see that one? See this one right here? Notice that that's where the graph crosses the y-axis. It's on the y-axis. We call that the y-intercept. Y-intercept. And that's going to come into play later on also. That's going to come into play lots of places. So your y-intercept is where the graph crosses the y-axis. Hence the name y-intercept. Okay, it's where the graph intersects or intercepts. If you think about a football player, here's the quarterback throwing the ball, and then all of a sudden a linebacker from the other team comes up here and intercepts it. Okay, so that's what we're talking about as far as a y-intercept. Okay, we shorten it as INT, intercept. Good. So let's do another one. We're going to plug our values in for x and find y. You can do this. Let's try it on our own. Go. So you plugged in 3, then you plugged in 1, then you plugged in -2, and hopefully when you plugged in 3 you got 0. When you plugged in 1 you got -2, and you plugged in -2 you got a -5. So these are your ordered pairs. Now this is typically what some people would call an T-chart, where you put the x values on this side and the y values on this side. I like to have room to work the problem in here so you can solve it, but I will not require what it is. Okay, so let's plot these points. So I have the point 3, 0, 1, -2, -2, -3. And then we draw a line connecting all of those. It'd be nice if we had a straight line right here. Okay, a line connecting all of those goes to the edge of our graph. Yeah, straight edge would have been good. Okay, a good straight edge, that ruler in your planner. You can use a ruler that maybe you have in your binder, or you can use your ID card. Okay, so now look at these, and look at this point right here. What do you think that's called? What do you notice that it is? The same point up here. That's called our X-intercept. And if we look at the definition of a y-intercept, you can probably do the X-intercept all on your own. Okay, an X-intercept where the graph crosses the x-axis. Okay, now I want you to look at these points, and this will come into play also. Notice on the x-intercept, my x-coordinate is 3, my y-coordinate is 0. And on the y-intercept, my x-coordinate is 0, my y-coordinate is 2. Okay, so pay attention to that, but I want you to be familiar with what a y and an x-intercept is. Okay, let's go to the next page. So number 9 is one that you're going to finish up when you do your homework. So we'll do some of these as notes, and some of them will be as homework. Okay, but number 10 is just a little bit different. And with number 10, what we're doing here is we have to get, notice with number 9, we have y by itself. So we want to get y by itself. Now this should look familiar. Remember when we wanted to do that? We want to get y by itself. You will see pretty soon we're not going to put a box around y, because that's what we're always solving for. So we're going to subtract 2x from both sides. So I get 3y is equal to -2x plus 12. Divide by 3. Oops, I'm going to come up here because I ran out of room. Okay, divide by 3 every single term. And this time I do want to do it to every single term. Okay, so we get y is equal to -2/3 x plus 4. Okay, so that's what's going to go in here, -2/3 x plus 4. And that's what we're going to be finding. Now you look at that and you're like, oh my gosh, and I didn't mean to throw you into the frying pan so quickly, but hey, why not? We're big people. So we want to figure this out. We're not going to use their values. We're going to use our own, okay? Because if I have a fraction, I don't want to graph a fraction. Yuck. I don't want to do that. So what we're going to do instead is we're going to pick things to make it not be a fraction. It's kind of like we're going to clear a fraction. So what could I multiply -2/3 by in order to clear it? Well, look at that denominator. If I multiply by 3. So if I pick a 3 here, that would work. And if I plug 0, that's always nice. And then I would always recommend picking a negative. So when I pick values, I pick whole numbers. I always pick 0. I pick a positive, I pick a negative. And if I have a fraction, I'm going to use that denominator or a multiple thereof. So I could have used 6 or 9 or 3, and again, the negatives of all those. So we're going to plug those in. And notice what happens here. My 3's drop out. They divide out to 1. So then I have -2 plus 4, and -2 plus 4 is going to give me 2. Do the same thing here. Oh, this one's nice. I have -2/3 times 0. And we know anything times 0 is just going to be it's just going to be 0. Now I have 2/3 times a -3. Now here, okay, and let me say, this was a -2 because these dropped out, they divided out to 1, so I have -2 plus 4, which is 2. Here my 3's drop out, but I still have a negative times a negative, so that's 2 plus 4, which is 6. So my ordered pairs are 3, 2, 0, 4, negative 3, 6. Okay, now I'm going to stop for a second. So one of the reasons I'm doing this is because what I want you to realize, if you ever have to graph anything, you can always make a table. And you pick the x values. Like I picked my own x values here. Okay, so, and usually they don't give us x values. They just say graph this. Okay, so pick x values that are convenient for you. And again, my recommendation, a negative, a positive, and 0. So now we're just going to plot these points. 3, 2, 0, 4, negative 3, negative 3, and 6. Okay, let's see if I have a straight edge of any sort here that I can use. So I'm going to just use this straight edge right here and draw a line. And there's my graph. Okay, so we're going to go to a simpler one so that you can practice actually just graphing. I'm going to go to number 14 next. So look for number 14. And we have to get y by itself. So move the 2x. Add 2x to both sides, and I get y is equal to 2x plus 8. This is way nicer than what I was giving you before. Okay, so we're going to go 2x plus 8. Now on this one, again, we're going to pick the x values. We don't have to worry about a denominator, so I'm going to pick anything. If I get to pick anything, I'm going to pick 1s and 0s, because those are easy to work with. So I'm going to pick negative 1, 0, and 1. You can pick anything, anything for the x values. But if I'm picking, I'm not going to make it hard. So I'm going to pick negative 1, 0, and 1. Now let's pause, plug those in, find out those y values, go. And you got 6, 8, 10. Good. Now if you pick different x values, you'd have different y values. You can write the order of pairs, but I just go right here. I just plug these two, plot these 2 points. So negative 1 and 6, 0 and 8. Ooh, we barely made it. And 1 and 10. Okay, so there's our graph right there. We got to the edge quickly, so that's not a problem. I'm going to use my straight edge to go the other direction, though. Let me draw it down here. Whoops. To the edge. Close enough. Good. Okay, so you get graphing of that. Let's go to number 11. I'd like you to try it. We're going to pick our own values. First thing we have to do is get y by itself. Go. So did you get y equals 2/3 x minus 5? Good. Okay. Now I reduced the 4 6. You could have left it as 4 6, but I'm always going to have it go smaller. So what numbers do you think we want to pick here? Well, of course we want a 0, we want a negative, and we want a positive. I'm going to pick 3 because I have a denominator of 3 and I want that to go away. So I'm going to take and plug that in. Let's do that. Everybody go. So let's check our values. We're going to have a negative 3 and a negative 7, 0, negative 5, 3, and negative 3. Hopefully those are all the same. And if we were in class, I'd say if you have any questions. But for now, just pause my video if you got different answers. I tried to show my work up here. This was a negative 2 minus 5. This was 2 minus 5. Okay, so hopefully that was okay. Let's plot those points. Negative 3 and negative 7. 0 and negative 5, and 3 and negative 3. Now, you'll notice they always come out to be a line. That's the whole point of this. These are all what's called linear equations. Everything we graph in this unit better be a line. Okay, if it's not, we did something wrong. So everything, these are called linear equations, okay, because they form a line. Good. Let's go to, oh wait, you know what, number 12 is right here. Let's look at number 12. Let's get y by itself. So let's divide through by 4. So I get y is equal to 3/4 x. And the reason we do it that way is so then we can, it's really easy to plug in. I forgot to erase those numbers. We're definitely not using those. What numbers do we want to use here, people? That's right, negative 4, 0, and 4. Let's go. We know this. Okay, so plug those numbers in. Go. So let's plot those points. Negative 4 and negative 3. 0, 0, and 4, 3. So when we draw that line in, take our straight edge, And we draw that line. Okay. Now, one other thing, just to make sure, notice that this goes through the origin. What is the origin? This point right here. That's called the origin. Okay, this point right here. It's the point 0, 0. That's the origin. That's where the two axes cross. So if we ever talk about the origin, we're talking about right here. This point right here is the origin. Good. Let's see what's next. And we might not do all of these. That one does the same. Oh, let's go to these. People always freak out when they see fractions. Okay, we've already done kind of something like that. No, let's do it anyway. Okay, so look at right here. Oh my gosh. Do we like 1/3 denominators of 3? Yes. So we're going to pick our x values. What do we want to pick, people? Yep, you got it. -3, 0, and 3. And we're just going to plug those in, and we're going to find out what it's equal to. Okay, so we're just plugging all of those in, all those x values. And again, you get to pick any x values you want. That's a 3, not a 2. So we get -1 plus 4, 0 plus 4, that's just a 3, not a -3. And this is 1 plus 4. So this one, notice here, you dropped out the 3's, but you still had a negative. So 1 times a -1 would be a 3. That's where we came up with 3. And let's plot those points. -3. This graph's a little confusing as far as I'm concerned. 0, 4, and 3, 5. And once again, nice little line there. Oh, and I'm so excited for the next section that we get to do in the book, the first section of the book, because it's just so cool. One of my favorites. Okay, you get the idea here. We're going to plug in what here? 2, 0, -2. Notice sometimes I do the negative first. It honestly doesn't matter which way you go. Okay, so I'm going to go back to number 15 for a second. These are cool problems. Look at number 15. On number 15, look, we have y equals -3. So that means y equals -3, and y equals -3, and y equals -3. So it's basically -3. You don't plug anything in. It's going to be -3 no matter what happens. So what does that mean x is? Well, it doesn't matter because I can plug in anything and the equation, because there's no x to plug in. There's no x to plug in. It's just y values. And that's what it says. Y equals -3. So I go to -3. If I were to plot that, go down here to -3. Where is y -3? Well, it's -3 here, and here, and here, and here, and here, and here. Do you get the point? Every place. And what kind of line am I drawing here? That's a nice little horizontal line. So when you have a problem like this, okay, y equals -3. What's x? Anything you darn well please. It can be 4, it can be -12, it can be 1,000, because it doesn't matter. Y is always gonna be -3. Okay, so wait on that. I want to come back to that. Look at 16. X equals 5. So what do you think x is, people? That's right, 5. Now, knowing what we just did over here, what do you think y is? That's right. Anything you darn well please. You can put it in there. And let's look at this one. What happens here? Where is x 5? Well, x is 5 here and here, because look at, we're looking at the x value. What is the x value? And here, and here, and here, and here. You get the point? Okay? And I don't mean that as a pun, but you get the idea of what's happening here. We're going to have a line that looks like this. Okay? Because it goes through the x-axis. What's y? I don't know. Be creative. 43, -72, 5. It can be 5. Y can be whatever it wants because x is 5, period. Doesn't make any difference. So let's go 127, just to be obnoxious. Okay? Now I want you to look at these two. Notice what happens on both of these, and we'll come back to these and revisit these again in standard form in lesson 3, I believe. Okay? So look at this. When I have a y value, what axis does it cross? Bam! The y-axis. Okay? Graph only crosses. Hey, how about if we spell it right? Crosses the y-axis. Graph only crosses the y-axis. It crosses the y-axis. That's so important. I'm going to erase it and write it better because it crosses. Okay? So in class, a lot of times, I have people show with their hand. I'm going to show with my pen. So see how it crosses the y-axis, crosses the y-axis, okay? And look at this one. What axis does it cross? The x, that's right. So if I only have one variable, it's going to cross that axis. So this one crosses the x-axis, crosses. So wham, it goes right here. That's my graph. It's going to cross the x-axis. Good. So if there's only one variable, that's the axis it's going to cross. If only one variable, that is the only axis it crosses. Okay? Good. Okay, so what I want you to do now is I want you to finish for homework. You're going to finish off all the problems that we haven't done yet. So it looks like 4, 5, and 6. 9 is not done. 13 is not done. 18 is not done. 19 and 20. Okay, so that's what you're going to be doing for homework in that section. Thank you.